All right, we are going to continue our convert between standard and polar forms of complex numbers, and then we're going to multiply and divide complex numbers that are in polar form. So remember, we learned what polar coordinates are in the last chapter. So remember, polar coordinates look like this: r, comma, theta, right? And remember, the polar coordinates, the r represents the distance from the pole, right? And then theta is the angle from the polar axis to the terminal ray, right? So just like we converted between x and y and r and theta, we can convert between a and b and r and theta. Okay, so in the last section, we learned how to write complex numbers in the standard form a plus bi, right? And so the rectangular coordinates for that was a comma b. So again, this a and this b is going to correlate to x comma y, which correlates to r comma theta. So we're gonna review the formulas to convert between rectangular and polar and back and forth. Okay, so here are the formulas that you need to remember. R is equal to the square root of x squared plus y squared. Okay, and theta is equal to tan inverse y over x. Okay, x is equal to r cosine theta, and y is equal to r sine theta. Sorry, y is equal to r sine theta. Okay, so we have these same formulas, conversion formulas, for complex numbers, right? Instead of x and y, though, we're going to have a and b. So we'll have r is equal to a squared plus b squared. Theta is equal to tan inverse b over a. You should recognize that. That was in the last section. Okay. So remember, the a and the b, those are the real part and the imaginary part for our complex number. Okay. So likewise, for x and y, we also have the formulas for a and b. A would be r cosine theta, and b would be r sine theta. So again, we just took these from the last chapter and replaced x and y with a and b, because the a and b are part of our imaginary complex number. Okay? So with these formulas, okay, we can take a complex number, a plus bi, and we can rewrite it as the polar form of a complex number. So now we need the polar form of a complex number. So remember, a is r cosine theta and b is r sine theta. So instead of saying a, we're going to say r cosine theta. Plus, instead of saying b, we're going to say r sine theta I. Okay? Well, I can go ahead and factor some things out, right? Let's factor out the r, right? So now I have r parentheses cosine theta plus sine theta I. There we go. Okay. And so you also need to know the abbreviated form. This cosine theta plus sine theta, people abbreviate that to CIS theta. So, of course, this is cosine, sine, and then the I in the middle stands for the I here, right? So again, the C came from cosine theta. The I came from the I for the imaginary number, and then the S came from the sine. Okay, so this is the polar form of a complex number right here. R CIS theta. Okay? So if we want to change from the polar form of a complex number to a rectangular form, we just have to determine the cosine and sine values for theta. That's it. That's all we have to do. So let's go ahead and look at an example of that. So again, we're going from, let's start with going from rectangular to polar. All right. So we're going to do 2 plus 2 square roots of 3i. Okay, awesome. So first of all, identify what's A and B, right? This is A and this is B. So remember, in order to go to polar, we need an R and we need a theta. Those are what we need if we want to be in polar. Okay, so let's use our formulas. R is the square root of a squared plus b squared. Theta is tan inverse b over a. Okay, so we'll use our a and b values. R is equal to 2 squared plus 2 square roots of 3 squared. All right, so 2 squared is 4 plus 2 squared is 4 times the square root of 3 squared is 3. And so we still have the big square root over all of that. So R is equal to the square root of 4 plus 4 times 3 is 12. And then 4 plus 12 is 16. So R is equal to 4. That's such a nice number. You're not always going to get nice numbers like that for R, just so you know. But that one turned out really nice, okay? If you don't get a nice number, leave it as a simplified radical. Just leave it as a radical. Unless your radical turns out to be, 4, square root of 16 is 4, that's fine. Go ahead and write 4. But if you get a decimal when you square root it, don't give me a decimal. Leave it as a simplified square root. Okay, so now we know what R is. Let's get theta. So theta is tan inverse 2 square roots of 3 over 2. Okay, so simplify that. That's really, theta is equal to the tan inverse of the square root of 3. So this is where you get your chart and you say, what angle is tangent the square root of 3? Okay, so you're looking, and you say, well, when theta is pi over 3, you get the square root of 3. So theta is pi over 3. Okay, so in polar form, remember polar form we said was R, cis, I don't know, should we call that cis theta? So our R was 4, and our theta was pi over 3. Done. Okay, so rectangular to polar, not so bad, okay? Let's go the other way. Let's go polar to rectangular. So we're going polar to rectangular. So for this one, we have 1/2 cosine pi over 6 plus I sine of pi over 6. And we want to change it to rectangular form. All right. First thing first is we have to distribute the 1/2. Distribute the 1/2. So we get 1/2 cosine pi over 6 plus 1/2 I sine of pi over 6. Okay, this is where you use your chart. What is cosine pi over 6? Well, cosine pi over 6 is the square root of 3 over 2. So we have 1/2 square root of 3 over 2 plus, what is sine pi over 6? Well, sine pi over 6 is 1/2. So we've got 1/2 I times 1/2. I'm going to go ahead and rearrange that and say 1/2 times 1/2 I. Almost done. Let's simplify this. This is the square root of 3 over 2 plus 1/4 I. Done. It's standard form. All right, so that was example 2. That one's a nice one. Going from polar to rectangular is not so bad. Okay? So we do have an issue, though. This is the catch, because you know there's always a catch. The catch is when theta is greater than 1/2. Ooh, greater than, not 1/2, pi over 2. Okay, so when theta is greater than pi over 2, there are issues. Okay, why is that? We'll look at the coordinate plane, right? So remember, this is 0, this is pi over 2, and this is pi, and this is, and then it goes all the way around, okay? This is 3 pi over 2, right? So in this quadrant, everything's positive. Nice, right? Positive, positive. But in this quadrant, not everything is positive, right? We've got negative, positive. And in this one, we've got negative, negative. And this one, we've got positive, negative. Okay? So our sines and our cosines can be positive and negative, right? So remember that sine is negative here, and then sine and cosine are negative here, and then that means cosine is negative here, okay? So that becomes an issue, all right? Oh, I reversed that. I'm sorry. It's cosine is associated with x, so this should be cosine, then cosine sine, and then sine. I knew that sounded weird when I said it. Sine's always associated with y, cosine's always associated with x. So since it's negative, positive, cosine's negative there. Okay. All right, so now that we know where our issues are, let's do a problem where we have to be aware of the issues. All right, so for this example, example 3, we want to change 3 size 3 pi over 4. 3 pi over 4 to rectangular form, okay? So first, we have to expand it. So remember, size actually means cosine 3 pi over 4 plus sine 3 pi over 4 times I. Okay, once we do that, then we distribute the 3. So now we've got 3 cosine 3 pi over 4 plus 3 sine 3 pi over 4 times I. Okay, so this is where we need to check 3 pi over 4, what quadrant is that in? Well, 3 pi over 4 is less than pi, but it's greater than pi over 2. So it's in quadrant 2, somewhere over here, quadrant 2, which means that your cosine is going to be negative and your sine is going to be positive. So this number here is going to be negative. So cosine of 3 pi over 4, when we look it up, it's negative square root of 2 over 2. So now we've got 3 times negative square root of 2 over 2. And then sine of 3 pi over 4 is going to be positive, so we've got the square root of 2 over 2. All right, so now we just simplify this out. This is going to become negative 3 square roots of 2 over 2 plus, and then this is going to become positive 3 square roots of 2 over 2 I. And now we are done. All right, let's talk about going the other way and having to watch out for signs, right? Like what quadrant you're in. For example, if we have negative 1 minus 4i, and we want to be in polar form, well, negative 1 minus 4i, that's going to be in quadrant 4. Okay, so if you're not quadrant 4, quadrant 3, I'm sorry, because it's negative and negative. So you're in quadrant 3. So if you're in quadrant 3, that means that your sine is negative and your cosine is negative. So when we get our final answer, we need to just make sure that we've got everything that's negative, okay? So first thing is first is we need, in order to go to polar form, we have to figure an r out and a theta out. So let's figure out r. Remember, r is a squared plus b squared. So a is -1, so we've got -1 squared plus -4 squared. Notice how I'm putting those negatives inside of parentheses, because if you don't and you put it in your calculator, you're going to get negative numbers. A negative number squared is going to be positive because negative is positive, so don't mess that up. All right, so -1 squared is 1, -4 squared is 16. All right, which means that r is the square root of 17. Okay, awesome. Now let's do theta. This is where we've got an issue. Okay, because when we do theta is equal to the tan inverse of b over a, we get theta is equal to the tan inverse of -4 over -1, which means that it is the tan inverse of 4. So this one's not on your chart, so you have to use your calculator. And when you use your calculator, you're either going to get 76 if you're in degrees, or you're going to get 1.33 if you're in radians, okay? So 76 degrees or 1.33 radians, that's in the first quadrant. That's an issue. We don't want to be in the first quadrant. We want to be in the third quadrant. So how do we get our angle from here to here? Well, remember, we add 180. So you can either add 180 to 76, or you can add pi, which is the same thing as 180, to your 1.33 radians. Okay? So your answer is either going to be 256 degrees, or it's going to be 4.47 radians. I would not recommend doing radians if you're not getting something that's on your trig chart, on your table that you have for trig. I would just stay in degrees if you're having to use your calculator. It makes it easier. Okay, so here we are, 256 degrees. So now remember, it's r psi theta. So it is square root of 17, because that's r, psi 256 degrees. Done. So the most complicated part was just knowing, well, we got an angle in the first quadrant, but we know it's supposed to be in the third quadrant. Okay, so we had to add 180. That was the most complicated part. All right, so let's talk about multiplying and dividing polar complex numbers. Okay, that sounded like a mouthful. It is. It's a lot. Okay, so first things first, we're going to have two complex numbers. Okay, we've got r1 cosine theta sub 1 plus I sine theta sub 1. That's our first number. Second number is r2 cosine theta sub 2 plus I sine theta sub 2. So notice the only difference is this is sub 1 and this is sub 2. Only distinction between the two numbers, because theta and r can be anything. Okay, so let's say you want to do a product. Okay, so I'm going to give you the product formula, and then I'm going to give you the quotient formula, and then it's all about plugging the formulas in. Okay, so if you do r sub 1 psi theta sub 1 times r sub 2 psi theta sub 2, this is what your formula says. Your formula will say r1 times r2 psi theta sub 1 plus theta sub 2. That's the formula. Okay? If you're dividing, so let's say you have r1 psi theta sub 1 over r2 psi theta sub 2, your formula says this: r1 over r2 psi theta 1 minus theta 2. Those are your formulas. All right, so let's do it in action. Okay, let's do some examples. Let's see, let's do product first, okay? We have 5 cosine pi over 4 plus I sine of pi over 4. That's our first number. And our second number is going to be 3. I'm sorry, that's supposed to be in parentheses. 3 cosine pi over 6 plus I sine pi over 6. So first things first, let's go ahead and write these all in our abbreviated form. So remember, this is 5 cis pi over 4. And this is going to be 3 cis pi over 6, right? It just makes it easier for us. Okay, so our formula for the product, right? So here, if we're going to do 5 cis pi over 4 over 3 cis pi over 6. Remember, we do R1 times R2, so 5 times 3. And then we do cis theta sub 1 plus theta sub 2, so pi over 4 plus pi over 6. Okay, so we get 5 times 3, 15. And then pi over 4 plus pi over 6. You could do it like this. If you do 1/4 plus 1/6 in your calculator, you get 5/12. So it's 5 pi over 12. Done. And that's it. Okay, that's the product. So now let's do quotient. Let's divide them. So we have 5 cis pi over 4 over 3 cis pi over 6. So our formula says R1 over 2, R sub 1 over R sub 2, so 5 over 3, okay, cis theta sub 1 minus theta sub 2, so pi over 4 minus pi over 6, okay? So in your so let's just do it, so 5/3, right, cis. So to figure out what pi over 4 minus pi over 6 is, do not put pi over 4 minus pi over 6 in your calculator. You're going to get a decimal. Know that pi is going to be in your numerator. Just accept it. Pi will be in your numerator. You just need to figure out what the fraction is. So what is 1/4 minus 1/6? In your calculator, put 1/4 minus 1/6. You're going to get a decimal. Hit math frac. And when you hit math frac, it should say 1 over 12. So 1 over 12 is the same as saying 1 pi over 12, which is the same as saying pi over 12. So there's your answer for the quotient. All right, that's it. Go ahead and try 2 through 6 evens.